In this video, I'm going to show you how you can do an analysis of completely randomized designs that have subsampling in JMP. If you haven't already watched this video on how to do it in SAS, you might want to start with that video because I go over some of the more theoretical points about what we're doing with this modeling. In this video, I'm just showing you, one, how to do this in JMP, and then I'm also going to show you how you can quickly do an analysis where you just average over the observational units. That was another strategy that I said you could do, and I'll show you how you can do that in JMP. You can also do that in SAS using the proc means option. So first thing is we need to bring this data into JMP. So let me go to File, Open, and let me bring in that CSV file. It's on my desktop, so let me just find it. There we go. And then I'm going to import this as data. So here's my data set. The first thing I always want to check is to make sure that treatment, replicate, and experimental unit are all classification variables. I specified that manually in SAS with the class statement, but here you have to do it ahead of time in JMP. So let me just make this nominal, make this nominal, and make this nominal. So I'll first just show you how you can do the random effects and the nesting in JMP, just like how I showed it in proc mixed. So we go to Analyze and then Fit Model, and then this window pops up. So I'm going to put strength as my response variable. I'm going to go ahead and move this down to minimal reporting. I'm going to move treatment to my model effect, and then I'm going to use experimental unit as my model effect. Now to introduce nesting, you see you have this nest option right here. You want to click on EU, select treatment right here, and then pick nest. So if you did that in the opposite direction, that would not be correct. So you want to do EU first and then nest that inside of treatment. But at this point, SAS still thinks that this is a fixed effect, or JMP still thinks it's a fixed effect. So to make it random, I need to highlight it and then go to Attributes, not Transform, but Attributes. Click on that red arrow and select Random Effect. And as soon as I did that, you'll notice that a method strategy popped up. So the first one is REML, which is recommended, but they also have EMS, which stands for expected mean squared. So we'll do REML to start out with, and by default, this is going to calculate degrees of freedom using that Kenward-Rogers correction that I showed you earlier. This is just something that's kind of going on in the background. Unbounded variance components, this is saying that it's possible that we could get negative variance components, but we'll just say that's okay. And leave it at that. And then I'll hit run. And here's my output. You can see these familiar quantities that we saw in the SAS video, 86,108 for my EU variability and 13,625 for my observational unit variability. It does give you some confidence intervals, which are not that great for small samples, so don't put too much faith into these being accurate 95% confidence intervals for these variance components. And we'll scroll down to the fixed effect tests. Here's that familiar, we got the right degrees of freedom, 16, same F ratio. And then you can do all of your usual effect details sort of options that we saw before with the contrast and things like that. It does have a tab for EUs, but we usually don't worry about that too much. So we usually do our analysis on just the treatment effects. If we go back to this, so one way, if you want to just re-show your analysis, rather than doing Analyze Fit Model again, you can click on this red arrow and go to Model Dialog, and it'll pop up the same window like you typed in before. Now this is going to look a little bit different, so now it's split it up into fixed and random effects into two different windows. That's one thing that you might find kind of annoying about how the model dialog looks a little bit different. So if I do this over again, but with the EMS method, I hit run, and let's kind of compare these side by side. So my R-squared values are being calculated a little bit differently. So I wouldn't use R-squared maybe too much when you have random effects. What does matter is we get the same sums of squares right here. So this overall analysis of variance, this is actually not really all that meaningful because this is actually testing simultaneously. Notice there's 23. This is going to be those degrees of freedom, these are going to be for testing both the treatment effects and also the experimental unit effects. So this analysis of variance overall doesn't really make a whole lot of sense right now. The only time you'd want to use this is to get the mean squared observation value. You would find that kind of right here, although it is repeated down here in the variance component estimates. So let's minimize that. Here it's showing you expected mean squared formulas. So this is actually giving you a little bit more detail, but not too much more than what the SAS output showed you when you use the type 3 method. Here are your variance component estimates. Notice it's not giving you any sort of confidence intervals here. It's just giving you the variance component estimates based off of that correction I showed you in class. Here's your test denominator synthesis. So it tells you that you have what your denominator degrees of freedom are. And here are your tests. So this test right here is looking at whether your sigma squared E, that experimental error, is significantly different. And these numbers match up from what we saw in the SAS proc mixed output. So I think that covers that part. Let me leave this up just to show how if I average over subsamples, I get the same thing. So if I want to just save this output to my data table, I'll click on this red arrow, go down to script, and then save script to data table. Look right here. As I do that, you'll see an extra thing pops up. There we go, fit model. I might want to rename it, so I'll click it twice and just call this REML analysis just to keep track of that. So if I want to average over the the observational units, then I'm going to go to Analyze and then Tabulate. So I have to actually create a new data set when I do this. So I want to average the experimental units for each treatment. So I'm going to put treatment and drag it right here. Then I'm going to take experimental unit and move it right up here. So here it's telling me how many observations I have. Let me move strength right here. And so what this is doing is it's just adding them all up. These aren't averages. So to make them averages, I click on mean and replace sum with mean. So here are my experimental unit averages. So now I have 24 experimental units and then 8 treatments. So I could just do an analysis on this. So here I'm finished with that. To make this into an actual data table, I click on this red arrow and I go to make into data table. And so this is a brand new SAS data set. I can close tabulate. And so I can analyze this using just like a regular completely randomized design. Analyze fit model, mean strength is now my response, and then treatment would be my only model effect. So I'm ignoring the multiple sources of variation. So let me click run and look at my F ratio. It is exactly the same as what I had before. Let me just bring that up to verify that. So here are my 2 tests. This degrees of freedom is not denominator degrees of freedom. So now this overall analysis of variance is just my treatment analysis of variance. And so you can see, maybe not so much here because this doesn't do ANOVA. Let me just quickly redo this and change it into the EMS method so we can compare sums of squares. So it's okay that these don't match up because this is pooling things differently. So let me close this. Let me close this. And we see that we get an identical F ratio. This MS number, not exactly sure why that's not matching up, but that's because it's calculating sums of squares differently. The point is that when I average over observational units, the ratios are still the same. The individual sums of squares can be slightly different, but the overall test is going to be the same denominator, same numerator degrees of freedom. So it will do all of your tests for your treatments the same way, but you will get slightly different estimates because you're averaging over observational units, so you're ignoring the observational error. So hopefully that showed you two different ways that you can do this analysis in JMP. This might be an easier way for you to do the analysis and get it over with, but if you're comfortable with estimating observational error, then I would go on ahead and use the method where you can look at the different variance components